Hey guys, so in this video we are going to go over the Unity visual scripting fundamentals and compare these new concepts to what we already know from Scratch. So let's start. Let's go back to our game in Scratch, and basically what we are going to do is to recreate the behavior of the crosshair. I mean, not all the behavior, but only this part. I'll leave this to the next video because it's a little bit more complex. But let's just review how the crosshair works. So basically, when we start the game, it runs this left part, and basically we move the crosshair to the center of the screen, we move it to the front layer, and we hide the crosshair. And we hide it because the game only actually starts when the player presses the ready label. And when the player presses the ready label, we show the crosshair, and the crosshair just follows the mouse pointer. So let's see how we can recreate this in Unity using the Unity visual scripting. So first, let's compare the concept that we need to understand to that we have in Unity so that we can move from Scratch into Unity more easily. So in Scratch, when we import a sprite, we have this code area where we can just drag blocks and we can connect one block after the other to create the behavior of that sprite. Now, in Unity is a little bit different. In Unity, what we have, so what we call here the code area is what we call a script graph in Unity. And basically, a script graph is a visual representation of our code in Unity. So the main difference that you can see is that while in Scratch, the code is represented by blocks, in Unity, the code is represented by what we call nodes. And each node is a node is each one of these boxes that you see right here. So a script graph is made of nodes. So we have these two main concepts, a script graph and nodes. Now, in Scratch, we connect blocks by connecting them one after the other or nesting them, like for example in this case. In Unity, this is a little bit different. Since we don't have blocks but we have nodes, we connect nodes using edges. And edges are these connections that you can see here connecting one node to the other. And the edges connect specific parts of the node. And these specific parts are called ports. And each node has what we call input ports or output ports. Input ports are basically the connections that allow the node to take in information from other nodes. And the output port is what allows the node to send information to other nodes afterwards. So you can see, for example, this node is using the output port, or we are connecting the output port of this node to the input port of this one. And in terms of ports, so we have input ports and output ports. And in each one of these cases, input or output, we have two types of ports. And basically, these are called control ports and data ports. So a control port is basically what defines the flow of our application. So when we connect an output control port to the input control port of another node, it says that, okay, run this node first and then run this one afterwards. So this basically just defines, okay, run this one, then this one, and so forth. This is what relates best to what we have in Scratch. And when we stack this block after this one, is the same as connecting this output port to this input port. Sorry. And then, besides the control ports, which define the flow of our code, we have what we call the data ports. And data ports basically define the flow of data, so data that passes from one node to the other. For example, this node is a node that defines time per second, and we are sending this time per second to these input data ports of the node to rotate. This will all make a lot more sense when we start working with it, but I think it's important to have like the main structure of how the visual scripting is organized. So we have a script graph has nodes, a node has ports, and we connect nodes using edges to connect the output port of a node to the input port of the other one. So this is basically it. Now, let's see how we can apply this in our project. Where do I have the project? Is this one. Okay, so first we are going to start by importing the crosshair, the sprite, and we're going to add it to our screen. So you see that when we import the crosshair and we add it to the screen, we need to adjust the layer. So right now the crosshair is behind most of the layers. And let me just go back here to see, I don't remember what layer we should place it. Oh, on the foreground, yeah. We are going to place it on the foreground, which is layer number 7. Okay, so to change the sprite layer, we come here, ordering layer, number 7. And I think it will, okay, yeah, it's behind the curtains, but that's okay because we don't want the player to shoot behind the curtains, so that's not a problem. So it's already on layer 7, and then we just position it at the origin. Now, one thing that we need to understand is that all this code that we do in Scratch, so all this resetting the sprite position and moving it to the front layer, we don't actually need to do it in Unity. Because in Scratch, what happens is that the sprites retain the position that they had when the game stopped. So for example, our game stopped and we can see the crosshair is here at the top. So if I don't reset the position of the crosshair when we start the game again, the crosshair will start from that position. Now in Unity this doesn't happen. So in fact we don't actually need to do this go to X and Y. We don't need to move it to the front layer or anything like that. But I'm going to use this as an example to start working, to show you how to start working with visual scripting. Okay, so we have the crosshair, and now we want to create a script graph and attach a script graph to our crosshair. So like I said before, in Scratch, when you create a sprite, the sprite already has like that code area where you just drag the blocks. Now in Unity, you don't have that code area automatically, so you need to create a script graph and attach the script graph to our sprite. So first, let's create the script graph, or not. We are not going to create a script graph. We are going to create a component that takes a script graph. So we cannot assign a script graph directly to a sprite. What happens is that a script graph is assigned first to a script machine, and the script machine is the component that takes the script graph. And it's just another component like the sprite renderer or the transform, like we talked before on the other videos. So if you want to add a new component, we come here to the new component, and I have this one, and you press script, and you can see that you have a component called script machine. So just press script machine. And now this is the component that takes the script graph. And you can see that you have like an input field here where you can assign a new script graph. And the script machine has, or you can have 2 different sources to apply a script graph to the machine. You can have a graph source or an embed source. When I change to the embed, you can see that I can no longer assign a new asset here. And an embed is basically a script graph that belongs to this script machine. So you cannot reuse it with other sprites. And I don't, to be honest, I don't exactly understand what's the advantage of having the embed script graph, so I didn't use it. But there is some advantages that I still don't know about. So we want to use embed. We always will use the graph. And to assign a new graph, you basically create a new one. And you can see that a graph is just like another asset in our project, just like another sprite or a theme or any other thing that we assign here in our project. A graph is also another asset. So let's create a new folder called scripts. And inside the scripts, we are going to create the crosshair. And you see that when we create the crosshair, it assigned the crosshair automatically here in the graph input field, and we also have the asset here. Now, once again, coming back to the graph source instead of an embed. When you create an embed, you don't have this X asset. So, which means that the code that you are going to create inside that graph only exists for that script machine, which is applied to that object. So let's say, for example, that in this case, since it is a crosshair, it's very specific to the crosshair, it shouldn't be a problem to have that as an embed. Because the problem is that when you want to reuse this graph to other objects, let's suppose that I want to use this crosshair not only on the crosshair, but other objects are also going to be using or sharing this behavior. then this is a big advantage to have the asset, because I can just assign this asset to multiple script machines, which I can't do on an embed when I'm using the embed source. But once again, I haven't used the embed, or I don't see the advantage. So I just use the graph source, and I always have the assets, even if I'm not using or reusing or sharing this behavior with other objects. Because in a way, and you'll see afterwards, if we go to the scripting, to actual scripting with code, this resembles more when you are using actual code. So when you are creating code, you create scripts, and you can reuse those scripts through how many objects that you want, and you actually have an asset. So I prefer to use it this way also. So we have a crosshair, and you can select, you can go here, edit graph, or you can select the asset and go to edit graph, and it will open a window where you can edit the script graph. And I'm gonna just dock this one here, and you can see that this is the area where we are going to add our nodes. This is, you can see that the interface is a little bit more complex. I'm not going to go over all the interface, so once again, I'm just going to go over on a need-to-know basis. Okay, so I'm not going to go over all the interface. As long as we need it, we'll go over each one of the areas and everything. So right now, what we need to focus is on this block that we have right here. And the main one that we need to understand right now is this onStart node. And this is because basically this node corresponds exactly to the block that we had in Scratch when the green flag is clicked. It's not exactly the same, but it's the most closely related. So when in Scratch, when we were using this block, when green flag is clicked, means that the code connected to this block runs when the game starts. In the same way, in Unity, when we use the node onStart, it means that the code connected, the node connected to this one will execute when the game starts. Not, in this case, not the game, actually. Now I'm saying the game starts, not exactly the game, but the object. I mean, the object needs to be active for it to start, but let's just keep it this way. So when the game starts, the code that is connected to this node will also be executed. And in this case, we are going to move the crosshair to the origin. Like I said, we don't need to do it in Unity, but we are going to do it either way so that we can use a few more nodes. So, and using this comparison that I have right here, you can see that the node that corresponds to this go to X and Y is a node called transform set position, and has all this that we are going to see in just a minute. And basically, why is this node? Because like we talked about in the previous videos, each sprite in our scene has, not sprite, each game object in our scene has at least this component called transform. And the transform is the component responsible for showing the game object in the screen. And it is a component responsible for saying, okay, where the game object is on the screen in terms of X, Y, and Z, the rotation of the game object, and the scale of the component of the game object. So if we want to change the position of a game object, we need a node related to the transform component that sets the position of the object. Now, how can we add that node here? We have multiple options. We can either just drag from the output port from this node, like this. You can see that it creates an edge automatically, and when you release it, it will open what they call the fuzzy finder. That has a list of all the nodes that we can use. There are a lot of them, so usually the best way is just to search for what you want. So, for example, let's say that I didn't know how the node was called, but I know that I want to change the position. So I say, okay, let me search for position. And you can see that we have a lot of stuff here with position, and we have the one that we want. So, okay, I want to change the position of my game object, and the position is defined by the transform component. So I want to change the position in the transform. Okay, so I have a node called transform colon set position, not colon, the other one, set position. I press enter, and you can see that it creates the node and automatically connects both of them. I don't know why it disappeared. It shouldn't disappear. It should be like, you see that, okay, this is strange. I don't know. Well, okay, sorry. I don't know why this is like invisible. It shouldn't be invisible. It should be like this one. You can see here. You see, like they are filled with white. I don't know. So, like I said, this is one of the ways to add a new node. The other way, just like if you press the right mouse button and select add node, you have the fuzzy finder again, and you could just add a node without connecting to anything. And then you could just like make the connection again to this one. Let's use this one. Okay, so this is the node set position. And let's talk about the input and the output ports of this node. So basically, what we have here is most nodes, uh, when they are instructions that make part of the code flow, they have the control ports, so the input and the output. So like I told you before, the control ports define the flow of our code. So we know that the code starts here and then it flows to this one, to this node right here. And if you want the code to flow to another node, we should connect to the output port of this one. So this is executed first, then this one, and then the other one. These are the control flow ports, and then we have these ports here below the control ports. These are data ports. So the first one here, let's talk about the input ports first. So this one here defines basically to what object are we actually setting the position. And by default, it's setting the position to this object. And this, the keyword this, is used when we are referring to the game object where the script graph is applied to. So actually, we don't need to change this. So because basically we are changing the position of the sprite where we are using the script graph. But for example, let's suppose that I wanted to change the position of another object, which is not the one that has a script graph. I could attach a reference to that object here, and instead of setting the position of the object that owns the script graph, it would change the position of that object. And then we also have the values to what we want to change the position to. So, and you can see here that we are changing the position to 0, 0, 0. If I wanted to change to something else, I can just change it here. Or if I wanted to have some dynamic value, like suppose that I wanted to feed the values here from some other variable or something like that, I could just connect another node to input the values to the position that we want to apply. In this case, we don't need to do it. And on the output ports, we have the control to connect the node that is executed later, and we have also this port that allow us to output the value of the position to another node. Let's say, for example, that I want to set the position on this sprite, so in this case the position 0, 0 on this sprite, and then I want to use the value of that position to another node. I could connect the output port of this node to another one to use the position on some other script graph, which we won't be using right now. So let's see, and let's just change the crosshair. So I'm just going to move the crosshair somewhere else, and you can change it here on the transform component. Let's play the game. It's taking a little bit. Oh, it's the first time running the visual scripting. Yeah, initial node generation. Yeah, okay. Let's just wait. So basically, right now, when we start the game, it will run this node, run this one, and set the position of the crosshair to 0, 0, 0, and you can see that the crosshair is now at the right position. Okay, so this was a node to change the crosshair position, and now we have the other one to hide. Like I said, we are going to ignore this one because we don't need to change the layer of our sprite, so we are going to hide our sprite in Unity. And basically, you also have a node for that. Let's go to the comparison right here. And you can see that while in Scratch we have these two blocks, so show and hide, in Unity we have a block related to the sprite renderer. And that's how we actually hide. I'm just going to restore the position of this one. So when we want to hide the sprite renderer, not show the sprite renderer on screen, we can enable or disable the sprite renderer component. And you can see that when I disable it, it just disappears from the screen. And when I enable it, it appears again. And so basically what we need is a node that controls the sprite renderer and sets enable or disable. So let's connect after this one, and we can say, okay, sprite enable. Let's see if we can get, okay, yeah, sprite enable. We have sprite render set enable. And this is what we want. So we connect the sprite render using the control flow, the control port, to define the flow. So run this node, then run this one, and then run this one. And here, similar to this one, we can also define to which sprite we are actually enabling or disabling. And by default, it's saying, okay, we are enabling or disabling the sprite to which the script graph is applied. And then we have a Boolean value that defines true or false. So if it's true, it means that it enables the sprite. If it's false, it disables the sprite. And basically what this does is exactly the same as we are doing right here, but through the visual scripting. And then, once again, we can also output the value, or we could connect another node afterwards. And now, let's just run the game. It should be quicker this time, I hope. Yeah, and you can see that the crosshair just disappeared, and it just disabled this component right here. And okay, and so basically this is our script in Unity. So the game starts, we reset the position of our sprite, and we disable the sprite render. And this right here is the equivalent to what we had in Scratch minus this go to the front layer, because we don't need it. But even if we need it, just for an example, let's say that we wanted to actually move to the front layer. Let me just say if I can find it. So sprite layer. And you have here, okay, set sorting, no, sprite mask, sprite render, which is what we want, and sorting layer ID. And we could use this because we can order in layer. Oh no, not sorting layer ID. No, not this one. This is what happened when I start like remembering stuff when I'm recording. But let's say, okay, sprite, okay, order layer. Okay, we don't have it. Layer. Sorting layer. Okay, so we have the set sorting layer or layer ID. Set sorting layer name. Okay, renderer, invisible, get enable, get material. Sorting order. This is the one that we want. Okay, so we could use this one. We could use this one to change basically the order in layer. But we actually don't need to do it because the order in layers don't change when we are running the game. So we won't do this. And so yeah, this is it about starting to work with visual scripting. So remember that when you have blocks, now you have nodes, and we use these connections to connect one node to the other one, and that's how you define the behavior of a game object in Unity. And this is it for this video. So in the next one, we are going to see how to recreate this part of the behavior of the crosshair. So yeah, I'll see you there, and thank you.